Good evening. My name is Gustavo Torres, engineering in training at La Salle University. In the original language of the article in question, I come to tell you about production and characterization of a novel artificial stone using brick residue and quarry dust in epoxy matrix. Abstract. Nowadays, there is an increasing tendency to reduce industrial residues in order to reduce their environmental impact. A typical alternative for a reduced residue is to be incorporated into a productive process that could be economically viable. Introduction: residues generated from practically all industrial sectors are more than ever of global concern owing not only to widespread environmental pollution but also questionable climate changes. Air, river, lake, ocean and ground pollution case are being accentuated by an increasing amount of industrial aces and plastic wastes and residues in composite materials is currently considered a modern solution. Materials and methods. A bricks residue CMOT and a dust residue quarry. The polymer used as matrix was the diglycidyl ether epoxy resin mixed with tritylene tetramine. Figure 1. Ternary diagram with the 10 mixtures based on the complete cubic model of the simplex. The determination of best baked composition for the CMOT was associated with the highest dry apparent density. Results and discussions. Table 1 presents the values obtained by the SLD method for the average density of vibrated mixtures of CMOT according to Figure 1. Table 2 presents the experimental result found for density, weighted absorption, and porosity of the novel AOS. Table 2 physical properties of novel artificial ornamental stone. Figure 2 shows the flexural stress versus strain curves or the neat epoxy resin reproduced with permission together with that for the novel AOS. Figure 2 flexural stress for strain curves for neat epoxy and AOS. Figure 3 presents ESM micrograph from AOS factory surface. In this micrograph image, one should observe a good adhesion between the epoxy matrix and the residue particles. Figure 3 scanning electron micrograph of the factory region of the AOS. Table 3 presents the result of wear test for the novel AOS and corresponding one reported elsewhere. Table 4 weight loss of after 24 hours chemical attack of AOS samples. Figure 4 depicts combined TGA DTG curves for the composite precursor epoxy quarrying, dust and came out. Summary and conclusions. Grad test revealed and reliability a small reduction in thickness, indicating that the new AREs would have the best abrasion resistance among other artificial stones and could be used for heavy traffic pavement. Thank you.